So look at this proposition that I've written here. For all y, if y is a friend of x, then y is a friend of z. This looks like it involves x, y, and z. It looks like it's saying something about x, y, and z. At least you see the symbols x, y, and z showing up. But in reality, it's only about x and z, and y is not involved because, well, look at how you can express this in plain English. This is just another way of saying all of x's friends are z's friends. And you see, there's no y. There's no y mentioned here. You could replace all the y's up here by some other dummy variable and it would not change the meaning. So in this proposition, which could be written in either of those ways, we would say, well, if you write it the first way or the second way, we would say x and z are free variables here. They are not bound. Whereas we would say y, especially if you write it the first way, where you can see the y showing up, but it's not really there, you would say the y is a bound variable. So what is in the symbolic formalism, what's doing the binding, what tells us for sure that y is a bound variable, is this fact that y is quantified by the for all. Now there are other ways for a variable to be bound. It could be quantified by there exists, or there's a third way which we will learn about soon today. So this is the general idea that in terms of meaning, when a variable is bound, that means it's not really there. You can see with the second way of writing the sentence, there are no y's. It's not really there. Let's just look at one more example here. Okay, so I've slightly modified the example. It still looks like it involves x, y, and z, if you just, look at the markings. And now it says for all y, if y is a friend of x, then there exists a z such that y hates z. So if I were to just write this part in plain English, it says y hates something. And if I write the entire thing in plain English, it says all of x's friends hate something. Now, that's kind of ambiguous. It's not clear whether it's saying there's this one thing that all of x's friends hate that one thing, or if each of x's friends has at least one thing that they hate, but they could be hating different things. It's actually the second one. So maybe to resolve that ambiguity, I could say it has something that they hate. All of x's friends have something that they hate. So you see now, it still looks like, y, x, and z, all three of them show up as markings here, but now the y is bound by this quantifier, and the z is also bound by a quantifier. So you see only x shows up here. So here x is free, and y and z are bound. So paying attention to which variables are free and which variables are bound really can help you make sense of what's going on when you're reading a proof or when you're writing a proof. For example, in this situation, if someone made this assertion here, then they haven't said anything. They've only said anything about x. They haven't said anything about y or z, because y and z are not really there. They're bound variables. So if they went on in the next sentence to start talking about y and z, they wouldn't necessarily be the same y and z showing up here. They would be some new symbols that are getting introduced.